Getting ready 15, we are starting off with multiplying some binomials, all right? Since everything we're looking at is simply a binomial times another binomial, multiply really means to us FOIL. Okay. So number one, first times first, x squared. Outers, negative 9x. Inners, negative 7x. Last, plus 63. Combine the like terms in those two middle terms there to negative 16x. And there's our final trinomial. Number two, first times first. Outers, inners, and last. So when we combine like terms, we see x squared plus 11x plus 24. Number three. First times first, 2x times 3x is 6x squared. 2x times 1, 2x. Negative 5 times 3x, negative 15x. And last, negative 5 times 1, negative 5. Like terms in the middle to combine and make 6x squared minus 13x minus 5. All right, switching gears, going in reverse now. Now we're looking at a trinomial and we are going to factor. So we first looked for a GCF. There is not one, and that's to be expected when you have a coefficient of 1 in front of the x squared. But we got to look. Our desired product for factoring is negative 28. Our desired sum, negative 3. So we need factors of negative 28. That means one positive and one negative. And they need to be different by 3. So the answer to that would be 4 and 7. Since I want the 3 to be negative, I want the larger of those two factors to keep the negative sign. The 4 will be positive. So x plus 4, x minus 7. Number 5, no GCF. We have a product, we're looking for 24. It's positive, so these signs will be the same. Since the desired sum is negative 10, that tells me both of these factors have to be negative. What factors of 24 add up to 10? That would be 4 and 6. So x minus 4, x minus 6. And finally, over here at number 6, we do have a coefficient in front of the x squared now, which makes it even more important that you check for a GCF. We don't have one, but we had to look. And that changes the process here. We still make our magic x, but we multiply a times c. So 3 times negative 2 is negative 6. We still look at the middle term for our desired sum, 5. So if the product is going to be negative 6, I'll need one positive and one negative. And that means I need factors of 6 that are different by 5. This is a very commonly missed setup because it's so simple to just go, oh, it's 2 and 3. 2 and 3 make 6 and they add up to 5. But we need them to be different by 5. We want a sum of positive 5, so positive 6 and negative 1. Those are not the overall factors. I don't put those into parentheses and move on to the next problem. These are just the factors I will use to break apart the 5x in the middle here. So I like to write the negative 1 first when I have different signs, negative 1x plus 6x. And I just keep the 3x squared in front and the minus 2 at the end. Now I have two sets of 2. We take out GCFs. What comes out of 3x squared minus 1x would be x. X times what is 3x squared? Well, I'd have to multiply by 3x. X times something is negative 1x. That would be negative 1. Out of the last two, 6x minus 2, the greatest common factor would be a 2. 2 times something is 6x, or 2 times 3x. 2 times something is negative 2. Well, that's times negative 1. The parentheses need to match, and they do. So one factor is 3x minus 1. The other factor comes from my two GCFs, so I put them together and get x plus 2. All right, the next set here says that we are factoring difference of squares and perfect square trinomials. That's great to know as we do it, but you normally don't know that going into a set of problems, going into a polynomial that you'll need to factor. So I'm not going to do these any differently. I'm going to still go through the entire process. If you recognize what you're looking at and you have a shortcut, use it. But I want you to know that this tried and true method will always work. So number 7, we looked for a GCF. We didn't have one. So my desired product is 9 and sum -6. Since the product is positive, I need 2 of the same sign. To get -6, they would both have to be negative. So what factors of 9 add up to 6? That's 3 and 3. So we end up x minus 3 times x minus 3. Now it's not an accident that they are 2 of the same factors. That's what makes this a perfect square trinomial. Perfect square as in, if you remember back to the area diagrams with the little tiles, the 2 sides of the square are the same. Well, that's what makes it a square. The 2 sides of it are the same, and we can rewrite this as x minus 3 squared if you want to. You don't have to. Number 8. This one, again, is a binomial. It's a lot better chance that you will recognize those because we only have 2 ways to factor binomials. We can look for a GCF, which we don't have here, or it could be difference of 2 squares. Our product, we're looking for -81, so 1 of each sign. There's no b term, so our sum is 0. So I want factors of 81 that are not different, meaning the square root of 81, 9. So I factor this as x plus 9 and x minus 9. Number 9. There's no GCF, so I want a product of 64. I want a sum 16. Since the 64 is positive, these will both be the same sign. To get positive 16, they'll both have to be positive. So what factors of 64 add up to 16? That's 8 and 8. So x plus 8 times x plus 8, or exactly the same thing as if you write the quantity x plus 8 squared. Number 10, we look for a GCF. We don't find one. So now notice this one does have a different a value. So I'm going to have to do that longer method if I do not recognize it right away as difference of 2 squares. Okay? So 9 times -25 is -225. There's no b term, so I'm looking for a sum of 0. So how can I use different signs and a number that is not different from the other factor? Well, that means I'm really taking the square root of 225, and that's 15. All right. So the 2 factors would be 15 and -15. Now, that would mean splitting up the middle term, and I don't have a middle term. Really, this is like 9x squared plus 0x minus 25. So I'm replacing the 0x with 15x and -15x. All right, so 9x squared minus 15x plus 15x minus 25. So what can come out of those first 2 terms? 9 and 15 both contain a 3. Each term has an x. 3x times 3x, 3x times -5. Here, out of 15x and 25, I can remove a 5 and be left with 5 times 3x times -5. So my factors are 3x minus 5 and 3x plus 5. Now, that did seem to be sort of tricky, difficult. So how could you have recognized this 9x squared minus 25 as the difference of 2 squares earlier? Again, it is a binomial. We have only learned 2 methods to factor binomials. One would be a GCF, so you check for that and don't find one. The second thing, difference of 2 squares. So it's the name really says what you're checking for. It is difference of 2, because it's a binomial, squares. So do you know the square root of 9x squared? And we would say, yeah, that's 3x. Do we know the square root of 25? Yes, that's 5. So if you've answered yes to all those questions, then you can automatically write the factors as 3x plus 5 and 3x minus 5, just using these square roots that you did probably mentally, and remembering that it must be one positive and one negative. All right, number 11. Now, we've kind of been breezing past that whole step where we look for a GCF, but here at number 11, we actually have one. All three of these terms contain a 3. So my first step is to remove that. 3 times something is 3x squared. 3 times something is 6x. And 3 times something is 3. Now, that doesn't mean you're done because you found a GCF. It means you did the first step. I still have a trinomial here that I have to attack like I factored all the other ones with the magic x. So I would have a desired product of 1 and a desired sum of 2. Product is positive, so signs are the same. Sum is positive, so they're both positive. What factors of 1 add up to 2? Well, 1 and 1. So I will still break apart this trinomial into x plus 1 times x plus 1. Don't forget about the 3. It's still one of the factors, right? You will never get back this original trinomial if you leave off the 3 from your answer, okay? Now, another way you could write that, since x plus 1 is there twice, you could write 3 times the quantity x plus 1 squared. In number 12, we're back to an a value of 1, so this will go a little quicker. There is no GCF. We make our little x. Our product should be 121, our sum negative 22. So same signs, both negative. What factors of 121 add up to 22? That's 11 and 11. So we get x minus 11 times x minus 11, or quantity x minus 11 squared. And our last section here is, just as we did the other day, just adding and subtracting. Remember, what you add, you can just ignore the parentheses and combine like terms right from the start. If it's subtraction, there's one extra step where you have to distribute that negative sign. So that's what we're looking at in number 13. We're going to distribute the negative sign into the parentheses behind it. So we see 11x minus 8. This turns into plus 9x and plus 4. 11x and 9x is 20x. Negative 8 and 4 is negative 4. Number 14, addition. So we can add like terms right away. Negative 2x and negative 5x, negative 7x. 13 and negative 23 is negative 10. 15, another addition. So a quick one, 7x squared and negative 2x squared, 5x squared, negative 4x and 15x, 11x. Another addition at 16. X squared and x squared makes 2x squared. 6x and negative 2x is 4x. Negative 17 and 14 is negative 3. Number 17, we have subtraction. Takes an extra step to distribute the negative. So that looks like 12x squared minus 5x. Turns that into minus 10x plus 9. So the only like terms are the two here in the middle. So we end up with 12x squared minus 15x plus 9. And one more subtraction problem at 18. Distribute the negative again. So rewrite as 4x squared minus 12x minus 27. Turn that into plus 3x squared minus 32x and minus 18. Right? To combine like terms, 4x squared and 3x squared is 7x squared. Negative 12x and negative 32x is negative 44x. And then negative 27 and negative 18 is negative 45.